Greetings, this is a lesson for Mr. Waddy's Math 3 class, and today we're going to be talking about real exponents and exponential functions. I do want to encourage you that hopefully you're able to sit down with either a partner or by yourself at a laptop and follow along, and I would like to encourage you just to pause at any time so you can make sure that you have all of the content written down, as well as rewatch some of these videos when you go back to do your homework, and hopefully their explanation will enable you to do so. So as I said, today's lesson is on real exponents and exponential functions. And we're going to be looking first at y equals 2 to the x. And it's going to require us to remember some of our properties of exponents, specifically negative exponents, just so we can evaluate some of those. So let's look at the function. As I said, y equals base is 2, and the exponent will be x. So in order to graph this, a good way to graph anything that we're not familiar with, I mean unless we have a graphing calculator, is to make a table of values. So we'll start by doing that. And we want to have a general idea of some negative and positives. So let's go from maybe -4 to +4. And so I'm just going to calculate some of these on the side with some scrap work here. So if I want to evaluate 2 to the -4th power, recall that our property of negative exponents, a to the -m, is equal to 1 over a to the +m. So the way we can simplify this is just merely by reciprocating and making its exponent positive. Recall that I used to just say move the negative guy downstairs, and then he's happy living downstairs. So we have 1 over 2 to the 4th is the way we could write that, and 2 to the 4th, let's see, we have 2 times 2 is 4, times 2 is 8, times 2 would be 16, so that's 1/16. So the y-coordinate would be 1/16 when the x-coordinate is -4. Similar things happen for the other negative exponents, so 2 to the -3 is 1 over 2 to the 3rd, which is equal to 1 over 8, or an eighth. 2 to the -2 would be 1 over 2 squared, or 1/4. So we have 1/8, 1/4. 2 to the -1 is just 1 over 2 to the 1st, which is simply 1/2. Recall that anything raised to the 0th power, another property that we have to remember, a to the 0 is equal to 1, no matter what the value of a is. So 2 to the 0th power in following suit will also be 1. And as a matter of fact, any of our exponential functions, no matter what the base is here, it could be any number, will always have a y-coordinate of 1 when the x-coordinate is 0. So that's one of the common traits of the exponential function family. So 2 to the 1st, these are a little bit easier for us to calculate, is 2. 2 squared is 4. 2 to the 3rd is 8. And 2 to the 4th is 16. And I think you can recognize the pattern going in this direction for the y-coordinates appears to be doubling, whereas the pattern going in this direction is simply halving. That's probably spelled with a V, but once again, I'm a math teacher. So notice that, you know, going the pattern in this direction, 16 divided by 2 is 8, divided by 4, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1, and then it does in fact confirm that these fractional values seem to make sense. 1 divided by 2 is 1/2, a half divided by 2 is 1/4, and so forth. So going in this direction, we're getting numbers that are smaller and smaller, but I would like to point out that going in this direction, no matter how negative this exponent becomes, it is never going to give us a negative number, right? If I repeatedly divide this in half over and over and over, I will get smaller and smaller numbers. However, they will never equal 0, right? Because I can't divide a positive number by 2 and end up getting 0. and they will also never be negative because dividing a positive number by a positive will give us a positive answer. So in this direction, we're going to be getting values that are closer and closer to 0, but never get there. And perhaps you recall asymptotes, and that is something that will be occurring in this situation. We had seen those in the past when we were looking at rational equations, when we had functions that looked like this. We had horizontal or vertical asymptotes. Something like that would occur. So we should have a similar effect here when we're graphing exponential functions. So now that I have my table of values, let's actually erase our scrap work here, and we'll consider what the graph of this will look like. So I would like to point out, first of all, as I said a moment ago, that there will be no negative y coordinates, at least without any negative sign in front of the 2 here. So I'm really interested only in the top 2 quadrants for our graph. So if I'm going from -4, -3, -2, -1, 1, 2, 3, 4, and let's see, we go as high as 16 and as low as a 16th. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I guess we could count by 2s. 4, 6, 8, 10, 12, 14, 16. And the half tick marks on our grid will represent singular units. So let's start just by graphing from 0 to 4. So when x was 0, y was 1. Alright, so we'd have a point right there. When x was 1, y was 2, so over 1, up 2. Alright, so nothing too fantastic just yet. When x was 2, y was 4. So it's right here. So I want to point out that it went up 1 unit and over 1, and now it's going up 2 units and over 2. So its slope is not consistent. It's actually getting steeper over time. When x is 3 units, y is 8. Once again, I'm pointing out that these y values are doubling. It went from 1 to 2 to 4 to 8, and it's just going to be growing steeper and steeper, faster and faster. So we'll end up with a curve like that. Now on the negative values of x, the negative x-axis, we'll see an interesting result as well. -1 has a 1/2 value for the y-coordinate, so it's halfway up between 0 and 1. -2 is at 1/4, then 1/8, and 1/16. And I'm getting numbers that are increasingly close to 0, and it's difficult for me to represent on this scale, but it never ever approaches 0. So what I have on this side, oh, I'm already going off, is a horizontal asymptote, which we can indicate with a dotted line. So we have a horizontal asymptote at y equals 0, right, which is the equation of the line, of a horizontal line passing through 0 on the y-axis. And then to the right side, this graph, and actually it is even technically doubling from 1/8 to 1/4, it doubled, to 1/2 it doubled, to 1 it doubled. So it's doubling over and over, so it's increasing faster and faster, and so this in fact is going up to positive infinity. So when we consider the domain of this graph, where that represents the possible x values, we're going from -infinity to positive infinity for the domain. So domain is -infinity to positive infinity, and those infinity is just represented by a sideways 8. And the range, I think we might be running out of room over here on the right side, will be, actually I'll just write it up here. We have values that are approaching 0, but not including it. So I'm going to have an open parenthesis there. So not quite 0. If it included 0, I'd have a square bracket here. But because it doesn't actually include 0, we use an open parenthesis. And it goes all the way up to positive infinity. And range, by the way, represents the possible y values. So that's the graph of a basic y equals 2 to the x function, all right, which is an exponential function. And we're going to use that kind of as a basis when we're considering the family of exponential functions. And they all will have this general shape, upside down, and depending on the value of the base here, it can actually affect that as well. So we'll use this as a basis, and I'll see you guys next example.